Hello and welcome to Relatable Code. In this video, we're going to talk about suspend functions in Kotlin. So let's get started. Suspend functions are a special type of function in Kotlin that can only be called from a coroutine or another suspend function. They have the ability to suspend the execution of a coroutine without blocking the thread on which the coroutine is running. This allows other coroutines to run on the same thread while waiting for an operation to complete, which makes an efficient use of resources. Creating a suspend function in Kotlin is very easy. All you have to do is to just use the suspend keyword. Okay, suspend fun is a suspend function in Kotlin. Let's create a suspend function which simulates fetching some user data, which will return a string. And inside the scope of this function, I can use functions like delay. Okay, this function delay can't be called outside the scope of a suspend function or a coroutine because delay in itself is a suspend function. Okay, and delay behaves like thread.sleep if you want. Okay, so here we're trying to delay this coroutine or this suspend function for 1 second, and after that we're calling a println statement, fetched user data, and in the end we will return user data. Okay, that's how you create a suspend function in Kotlin. And as with the delay function, you can't call this function inside the onCreate function because the onCreate function is not a suspend function. Okay, and you will get this warning here. Suspend function fetch data should only be called from a coroutine or another suspend function. Okay, and you may notice this sign here at the left. If you hover over that sign, it will confirm that this is a suspend function call, and it's referring to the delay function right here. Okay, and that's how you create a suspend function in Kotlin. If you want to call this function inside the scope of an activities on create, you have to create a coroutine. Okay, and one way to create a coroutine, the simplest way is to use coroutine scope dispatchers.io.launch. Okay, we will have a separate video about the different types of coroutines which we can create, but for simplicity reasons, we're going to use this coroutine. Okay, and we're going to call this function fetch data inside the scope of this coroutine. And if you notice, it will no longer give us an error because it was indeed called inside the scope of a coroutine scope, as you can see right here. Okay, and now if you run your application, you're going to see a simulation for 1 second, and after that you're going to see this println statement. Okay, so open your logs and filter here for tag system.out. Okay, after that, clear your logs if you have any, and run your application. And there you can see this log will get displayed after 1 second. And if you think that this didn't wait for a second, you can add a println statement right there before you call your coroutine scope, clear your logs, and launch your application again. The app will get launched again. If you open your logcat, you will see that you have this println statement started at this time, and you have fetched user data at this time. Okay, and if you compare those two timestamps or 2 times right there, you will see that there's a second between them. Okay, and that's because of the delay happening inside our suspend function. So let's add another suspend function to see them in action. We currently have a fetch data function. I'm going to create another suspend function to process data. Okay, it will expect this data as a string. It will also delay for 1 second before writing a println statement with fetched if you want, or not fetched. data retrieved, and you can use your data right there. Okay, that's how you create the process data function. And here, instead of directly calling the fetch data function, we can assign it to a string because it does return a string. So let's create one with val data equals to fetch data. And after that, we can write process data. Okay. And after that's done, you can clear your logs right there and run your application again. Let's check our logs. There we have them. We have started app at this time. And after 1 second, we had fetched user data. And right there, after another second, we have data retrieved, user data. Okay, that's how the coroutines worked inside the scope of our coroutine scope. Okay, so first, this coroutine was launched, which had a delay of 1 second. That delay happened, and after that delay, the coroutine, or the suspend function in this case, resumed to perform or execute this block of code. And after that, this function was called after we had retrieved this data. Another delay was issued for 1 second, and after that we had this println statement, okay, which confirms that suspend function do in fact have the ability to suspend and resume execution. Okay, they suspended execution for 1 second right there, and they resumed after the delay was done. Okay, and same thing for our second function, our process data function. Okay, so how do suspend functions work in Kotlin? You can think of suspend functions like reading a book with multiple bookmarks, for example. You can pause or suspend your reading at one bookmark, which is called a suspend point in a function, and do something else, which will allow other operations to run. And then after that, you can come back to continue reading from where you left off, which will, in our case, resume the function. So in your main activity, when you call a suspend function like fetch data, Kotlin under the hood handles this like putting a bookmark inside your book. The coroutine says I'm going to wait or suspend in our case until fetch data has fetched the data. Okay, but in the meantime, I won't block the thread that I'm running on. Other tasks or coroutines can use this thread if they need to. Okay, so once fetch data has completed its work, the coroutine is notified, and it resumes to proceed with the next line of code, which in our case is process data. Okay, let's create another suspend function to get a better grasp of this idea. Let's create a suspend function right there to fetch news, for example. Okay, this function will delay for I wrote fun. We're having a lot of fun with suspend functions. That's a really bad joke. And after that, we can write println fetched news. Okay. What do you think will happen if we use this fetch news after we fetch our data and before we process our data? Let's clear our logs and rerun our application again. Open your emulator and now check your logcat. As you can see, first we have started our app. After that, we fetched our user data. And after that, we had fetch news. Okay. And this happened exactly 1.5 seconds after we fetched our data. Okay, because this will happen sequentially inside the scope of a single coroutine. First, our fetch data will get executed, which will wait or suspend a whole second before issuing this println statement. And after that, we have fetch news. Okay, inside fetch news, we also have to suspend 1.5 seconds, which you can see happened right there before this println statement was executed. And after that, we had process data as the last step. Okay, with processed data, we had another delay of 1 second, as you can see, before this print line statement was written right there. Okay, well, what if I want fetch news to run independently of these two functions? In that case, I can create another coroutine. Okay, and you can do that like this. Dispatchers.io.launch. You can copy fetch news right there, clear your logs, and run your application again. Okay, there we have our app, and if you open your logs right now, you will see that you have start app at this time, and after exactly 1 second we had fetched user data right there. But now you can see that the difference between fetch news and fetch user data is half a second. Okay, and that's because those two coroutines were running in parallel. Okay, so after fetch data, which had a delay of 1 second, 500 milliseconds were remaining so that the news can be fetched. Okay, because fetching our news takes 1.5 seconds, meanwhile fetching our data takes 1 second. Okay, so instead of waiting 1.5 seconds between both of these functions, instead they both had to run in parallel in this case. Okay, and data was retrieved, as you can see, half a second after the news were fetched. Okay, because fetching news takes 1.5 seconds, but retrieving data takes 1 second and another 1 second, which equals to 2 seconds in this case. Okay, I think that was a lot of explanation for these seconds at least, but I want you to know how these coroutines work and how these suspend functions work inside those coroutines. Okay, so if you notice, suspend functions only suspend the current coroutine that they're running in. Okay, they don't suspend other coroutines as well, which is why we had the capability of running those two coroutines in parallel. Okay, so suspending the first coroutine didn't suspend the other coroutine, which had our fetch news function. And that's one of the key properties of suspend functions and coroutines in Kotlin. Okay, so here you can distinguish between normal functions and suspend functions because regular functions, in our case, execute in a blocking manner. Because when you call a function, the program must wait for the function to complete before proceeding. Meanwhile, with suspend functions, they are non-blocking. They can pause their execution or suspend in our case and resume later, which will allow other operations to run at the same time. Okay. Regular functions, however, can be called from anywhere inside your code. Meanwhile, suspend functions can only be called from inside a coroutine scope or another suspend function. Okay. Suspend functions are designed for asynchronous operations within coroutines, allowing them to suspend and resume without blocking the main thread. They are essential for writing efficient, non-blocking, and easily readable asynchronous code inside Kotlin applications, especially when dealing with any task that requires waiting, like network calls or database operations, for example. They promote a more linear programming style, even in the context of concurrency, simplifying the development of complex asynchronous logic, which is normally associated with callbacks and futures or promises. If you like my type of content and you find it to be relatable, please don't forget to leave a like and subscribe for future content, and I'll see you in the next video.